Hello mathematicians, this is the video for the Unit 3 review sheet number 1. And remember, review sheet number 1 and review sheet number 2 will look just like the test. So if you're going to study anything, study these. Number 1, write 3 equivalent fractions to represent the shaded part. 6 are shaded out of 24 total. So 6/24 would be a good fraction. I will accept any equivalent fraction. To find an equivalent fraction, whatever you do to the numerator, you have to do to the denominator. Double the numerator and double the denominator. Multiply the numerator and denominator both by 5. Multiply the numerator and denominator both by 10. Divide the numerator and denominator by 2. As long as you do the same thing to the top as you do to the bottom, you will get an equivalent fraction. For example, I could cut the top in half and cut the bottom in half. That's an equivalent fraction. I could divide the top by 3 and divide the bottom by 3. That's an equivalent fraction in its most simplified form. And if you look at the picture and you cut it into 4 chunks, you can see that 1 out of 4 are shaded. Remember, you can also multiply the numerator and denominator by the same thing. For example, if I multiply the top by 2 and the bottom by 2, I would also accept something like this, 12/48. Okay? So as long as you do the same thing to the top as you do to the bottom, you will get an equivalent fraction. There are an infinite number of possibilities. The second picture, I can see that there are 16 squares, 4 of which are shaded, so 4/16 would work. I could simplify. I could cut the top in half and the bottom in half. I could do it again, cut the top in half and the bottom in half. That one's 1/4 as well, and you can see that if you split up the picture into 4 sections. You also could multiply the top and bottom by the same thing. Maybe for this one, let's multiply the top by 10 and the bottom by 10. So I would also accept something like this, 40/160. As long as you do the same thing to the top as you do to the bottom, you will get an equivalent fraction. You only have to have 3, and as long as they are mathematically correct, I will accept them. The last one, there are 100 squares, and I can see that, let's see, if I think strips, I can see that 5 of them are shaded, 5 out of 10 strips, or I could think 50 out of 100 units. I also could, for example, double the top and double the bottom, and write 10/20. That would work. Right? So as long as I do the same thing to the numerator as I do to the denominator, I will get an equivalent fraction. Number 2, Susie wrote this equation. Equation! So make sure that all 3 equations have an equal sign, and they all must equal 1 2/6. So imagine breaking 1 2/6 like up into sections and showing like adding a bunch of sections together, or even a subtraction problem would work. Here would be an example. There are lots of possibilities. Here is one of them. How about this? How about a big old 1 plus 1/6 plus 1/6? That equals 1 2/6. Another equation, how about a subtraction problem for this one? What if I did 1 3/6 minus 1/6? That equals 1 2/6. And another way to get 1 2/6, how about 3/6 plus 3/6? Right? That's 6/6 or 1 whole. Plus another 2/6. That equals 1 2/6. There are a lot of possibilities. As long as it equals 1 2/6 and it's an equation, it will be acceptable. So notice that each equation equals what it's supposed to. Okay? On to page 2. Don made 2 pans of cake that were exactly the same size. He cut the first pan into 3 equal pieces and the second pan into 5 equal pieces. He gave 2/3 of the first cake to his uncle and 3/5 of the second cake to his next door neighbor. Don's little sister Anna said, "That's not fair. The next door neighbor got more than the uncle." Don said they got exactly the same. Who is correct, Don or Anna? That is a lot of words. Word problems often need to be read more than once. So here's the question. 2/3 went to the uncle. 3/5 went to the next door neighbor. Anna says that's not fair because she doesn't think those are the same. Don says it is fair. They're exactly the same. So we need to decide, is Don or Anna correct? So we need to compare those two fractions. I am very good at drawing pictures because I do it so often. Check it out. Even if you're awesome at drawing pictures, look how crazy similar they look. If I were to draw 2/3, for thirds looks like a peace sign. And if I were to draw 3/5, and fifths sort of looks like a star. Fifths are pretty hard to draw. Can you tell that those pieces look pretty similar? Almost too similar to be able to tell which one is bigger. So, if you can't tell based on your picture, think this. The denominators are not the same. In order for me to know totally if one is bigger than the other, or is Don right, are they the same, I need to make the denominators the same. One of the denominators is 3. One of the denominators is 5. And I'm thinking, what can I make a 3 into, and what can I make a 5 into? Oh, I could make them both into a 15. If I multiply the bottom by 5, that equals 15. If I multiply the bottom by 5, I have to multiply the top by 5. 2/3 is the same thing as 10/15. For my second fraction, if I multiply the bottom by 3, I'll get 15 as well. And if I multiply the bottom by 3, I better multiply the top by 3. No wonder my pictures looked so similar. Look how close the fractions are. 10/15 and 9/15. Don said they're the same. Don was not correct. The little sister, she was correct. She was right. It's not fair. They didn't get the same amount of cake. One is slightly bigger than the other, right? This fraction is slightly larger, which means Anna was totally right when she said, that's not fair. They weren't the same amount. They were close, but they weren't exactly the same. Number 4, June ate 1/3 of a pizza. John ate 1/5 of a pizza. Alan said, John ate more pizza than June because a fifth is always more than a third. Common mistake. That's what a little kid would agree, but I do not agree with Alan. A fifth is not more than a third. I know the bigger the denominator, the smaller the fraction, the smaller the pieces. And these are different enough that you can tell. If I make 1/5 versus 1/3, I can tell that not 1/5 is bigger, 1/3 is bigger. Remember, the bigger the denominator, the smaller the fraction. So Alan was not correct. Number 5, Andy says 4/10 of the grid is shaded. Rella says no, 40/100 of the grid is shaded. Who is correct? Stop arguing, you two, because both of you are correct. And the way that you could explain it, you might use like a sentence of sorts, and you might say something like 4 strips is the same amount as 40 units. Or maybe you'll show it with numbers and show that when you multiply 4/10, when you multiply the bottom by 10 and the top by 10, you get 40/100. So this mathematically is showing that 4/10 is exactly the same as 40/100. They're both correct. 4/10 and 40/100 both match the picture. On to page 3. Number 6, fill in the blank, less than, greater than, or equal to. For most of these, I want you to think this. If the denominators are not the same, Next one, 3/4 versus 5/12. I'm going to write a little small, and I'm going to sneak this in. 3/4. I multiply the bottom by 3, and then, of course, the top by 3. 3/4 is the same as 9/12. Now they're easy to compare. What's bigger, 9/12 or 5/12? 9/12 is bigger. The one right next to it, again, make those denominators the same. I only have to change one of them. If I double the bottom, and of course double the top, 1/4 is the same thing as 2/8. What's bigger, 2/8 or 2/8? They're equal. Down below, 45/100 and 6/10. Again, make those denominators the same. And I can do this just by adding a 0 to the top and a 0 to the bottom. If you multiply the top and bottom by 10, 6/10 is the same thing as 60/100. Now they're so easy to compare. 45/100 versus 60/100. 60/100 is bigger. Next to it, again, make those denominators the same. If I double the bottom, I have to double the top. 3/8 is the same thing as 6/16. And 6/16 is bigger than 4/16. Below that, 70/100 versus 7/10. 7/10 is also the same thing as 70/100. So they are equal. And the last three, all decimals. Remember, if one of the decimals goes up to the hundredths place, remember that little trick of making them all go up to the hundredths place by adding some zeros? It just makes it way easier on your eyeballs to comprehend which one's bigger. If I add a 0, they both go up to the hundredths place. Maybe even think of money. Money is easy for kids to comprehend. What's bigger, 20 cents or 20 cents? They're equal. And the last row in this section, if I add a 0 and think, what's bigger, 33 cents or 40 cents? 40 cents is bigger. And the last one, they both go up to the hundredths place, and they both have the same numbers, but they're in a different order. That makes a difference. What's bigger, 2 cents or 20 cents? 20 cents is bigger. Number 7, this section, we have to write each fraction as a decimal. The first one is 68/100ths. That means it goes up to the hundredths place. You don't have to make those little lines, but it can be very helpful for some kids. So I'm just going to fill in a 68. It looks like a 68. It goes up to the hundredths place. 3/10 is a 3 in the tenths place. 1 and 55/100ths. I see a big old 1 and 55/100ths. Our whole number goes before the decimal. Our fraction of a number goes after the decimal. So I have a big old 1 in my fraction. I need a big old 1 in my decimal. And it goes up to the hundredths place. And the last one, 3/100ths. Make sure that 3 goes in the hundredths place, not the tenths place. This might be where those dashes come in handy. I need a 3 in the hundredths place, which means I need a 0 there, 0.03. Number 8, now do the opposite. Write each decimal as a fraction. I see an 8 in the tenths place, 8/10. Right next door, I see a big old 1, so I need a big old 1 in my fraction. And I see a 6 in the tenths place. I see a 4 in the hundredths place. And I see a 72, and it goes up to the hundredths place. Number 9, add or subtract. 2 of them are adding, 2 of them are subtracting. It would be a shame to know what to do, but accidentally do the wrong operation. So remember, 2 of them are adding, 2 of them are subtracting. Number 9, oh, I need to think it again. If the denominators are not the same, 5/10 versus 31/100ths. So I'm going to make the first fraction have a 100 in the denominator. Now they're easy to add. 50/100ths plus 31/100ths equals 81/100ths. The one right next to it, already easy. The denominators are already the same. A big old 3 plus a big old 4 is a big old 7. 1/8 plus 4/8 equals 5/8. Down below, a subtraction problem. Do you notice what I notice? I don't like the way this subtraction problem looks because you can't do the 1/5 minus 2/5. So I'm going to change my mixed number to an improper fraction. I'm thinking fifths. One whole is 5/5 plus one more would be 6/5. Now I can subtract. 6/5 minus 2/5 equals 4/5. Remember, when all else fails, draw a picture. If your brain is like, say what, Mrs. Judson, on this one, totally draw a picture. I'm going to draw a picture of 1 and 1/5. The only problem is these are kind of hard to draw. Do like a rectangle and split that one up into 5 pieces. Okay, so I'm going to draw 1 and 1/5. And I need to subtract 2/5. So I could literally turn my pencil around and subtract 2/5 by erasing, and that would help me figure this one out if I was a little confused. My eraser might be bigger than my section, so I might erase a bit of my circle, but here we go. Erase 1/5, erase 2/5. And I can see that I have 4/5 left. So if the problem is confusing, try drawing a picture and see if that helps. Last one, 48 hundredths minus 2/10. Again, make those denominators the same. Now I can subtract. 48 minus 20 equals 28, 28 hundredths. Okay, number 10. 3 times 1/4. Say what? 3 times 1/4. That just means 3 1/4. So I'm going to draw a picture, and I'm guessing that you'll say, oh, that makes sense after you see it. So I'm going to draw a picture of 1/4, and I'm going to clone it so I can show it 3 times. That is what 3 times 1/4 is. How many fourths are there altogether? There's 3/4. So 3 times 1/4 is 3/4. Notice 3 times 1 is 3, and the denominator stays the same. So that's another way people do it, but you could also use a picture to help you really understand what 3 times 1/4 means. All right, the last one, 5 times 2/4. Say what? Okay, I'm going to draw a picture, and I'm going to draw 2/4. And 5 times 2/4 just means 5 of those. So I'm going to clone it. So we have 5 2/4. Okay, if that helps you visualize it. And now I'm just going to count the fourths. Count with me. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4. I would totally accept 10/4. However, probably the best thing to do would be to change it to a mixed number. I can imagine pulling 4/4 out. There's one hole. I can pull another 4/4 out. There's another hole. That equals 2. And I have 2/4 left. I could even simplify that to 2.5 as well. I would accept all of those, okay, as the right answer. And you could see, if you were to put these together, it is 2.5, right? See if this makes sense. If I took this away and put them there, and took that away and put them there, do you see what's left? 2.5, there it is. But you could just draw this picture and take 10/4 as your answer. All right, on to page 4. Carla is sewing 2 buttons on her shirt. She has 3/8 of a yard of purple thread and 1/2 a yard of pink thread. Which piece of thread is longer, purple or pink? So I'm comparing 3/8 versus 1/2. Do you know that if it was 1/2, it would have to be 4/8, right? So I think pink is going to be longer, but let me show you why. I could draw a picture, although it's thread, so drawing a circle could be kind of weird, I suppose. So maybe I'll just think this. If the denominators are not the same, so I'm comparing 3/8, and I'm totally going to use the colors that they are. 3/8 we'll put in purple, and 1/2 will make pink. Okay. If I make 1/2 have a denominator of 8 as well, it's 4/8, right? And 4/8 is bigger than 3/8. So can you tell that pink is longer? Because 4/8 is bigger than 3/8. So again, if you make the denominators the same, you can tell which one is bigger. You could draw a picture too and notice which one had more shaded stuff. And even though they're talking about string, that picture would still help. Okay, number 12. Jim ran 65th hundredths of a mile. Natalie ran 3/10. Who ran farther? If the denominators are not the same, Natalie was 3/10. And if I multiply the bottom by 10 and the top by 10, you already know this. 3/10 is 30 hundredths. And 30 hundredths is less than 65 hundredths, right? So this was Jim and this was Natalie. So who ran more? Jim did. And the last one, how much of a mile did the two run in all? Well, now that we made the denominators the same, adding is super easy. All I have to do is the Natalie number plus the Jim number, and the denominators are already the same. So they almost ran a whole mile, right? 95 hundredths is almost a whole. So together they almost ran a whole mile. So I'm going to write that my answer is 95 hundredths, if y'all write, of a mile. Okay? Last page. Number 13, the Jones are having a barbecue for 4 people. They want to give each person 3/5 of a pound of chicken. How much chicken will they need in all? I would draw a picture. Really what we're doing is 4 times 3/5 is really what we're doing. But drawing a picture could help. And cutting things into fifths, again, is hard. So don't worry if your pieces aren't perfect, because we're not comparing anything. So it's okay if your pieces aren't perfect. I'm going to show this mathematically as well. Okay, so 4 people. Here's one person. 3/5 for you, blue person. 3/5 for you, purple person. 3/5 for you, red person. And 3/5 for you, teal person. Okay? So that's all 4 people, and they each got 3/5 of a pound of chicken. And can you tell that it's a big old 2 and 2/5? So the answer is 2 and 2/5. I'm going to show you mathematically how you could do it for people who are really talented with their fractions and decimals. Check this out. I'm going to do 4 people times 3/5. If you remember from 2 pages ago, you could do this. 4 times 3 is 12. 12/5. And 12/5, pull out 5/5. There's a whole pound of chicken. Pull out another 5/5. There's another pound of chicken, right? That's 10/5 with 2 more fifths. So you could do it with a picture. You could do it with numbers. Mr. Jones loves leftover barbecue chicken, so he decides to buy more than he needs. He buys 3 pounds of chicken. How many pounds will he have left over? You can see it right here. How many pounds will he have left over? He has 3/5 left over. I also could go like this. He buys 3 minus 2 and 2/5. That's the subtraction problem we're doing. And I can tell that To get from 2 2/5 up to 3, that would be 3/5, right? And you can see it in the picture as well. You also could do this if that's confusing to people. Instead of 3, I'm going to call it a big old 2 and 5/5, which is exactly the same thing as 3. And then subtract 2 2/5. A big old 2 minus a big old 2 is a big old 0. 5/5 minus 2/5 is 3/5. So these are the same thing, but maybe this one looks better on your eyeballs. But you can also see it up in that picture, that there are 3/5 of a pound left, right? 3 whole circles minus what they ate, 3/5 left. Okay, last one. The 4th graders are painting one of the walls under the covered area on the playground. They started with 2 1/3 gallons of paint, but it wasn't enough. So one of the parents bought more, 3 2/3 gallons of paint. How much paint did they have in all? A big old 2 1/3 plus a big old 3 2/3. A big old 2 plus a big old 3 is a big old 5. 1/3 plus 2/3 is 3/3. 5 3/3 is really better written as 6 gallons of paint. Letter B. In the end, though, they didn't need that much. They only needed 5 2/3. How much paint did they have left? So we're going to take our total that we just figured out, 6, minus what they actually used. And that equals 1/3 left. Okay? And if that doesn't look quite right on your eyeballs and you want to say 6 is the same as 5 3/3 because it makes the subtraction look better, you could do that. A big old 5 minus a big old 5 is a big old 0. 3/3 minus 2/3 is 1/3. So this might be a better way on your eyeballs, but maybe you understand that way as well. Okay? All right, kiddos, let's look at the answers one last time. Page 1. Page 2. Page 3. Page 4. Page 5. Remember, when all else fails, draw a picture. Make sure you look over review sheet 1 lots and lots, watch the video lots and lots. Do the same thing with review sheet 2 so you feel fully prepared for the test. All right, kiddos, I'll see you in class.